So, good day everyone. In this video, we will going to discuss the object of equilibrium and the Allenbert's principle. So, mauna muna tayo sa object of equilibrium. So, what is equilibrium? So, when all the forces that act upon an object are balanced, then the object is said to be in a state of equilibrium. So, yung balance na nag-a-act sa isang object is balanced. So, malalaman natin na balance ang isang force if the right forces are balanced by the rightward forces and the upward forces are balanced by the downward forces. But this, however, does not necessarily mean that all the forces are equal to each other. Consider this object. So, these two objects are at equilibrium since the forces are balanced. We have 50 Newton in upper. Sa downward, we have 50 Newton, 30 both sides from left and right. So, balanced. So, if an object is at equilibrium, then the forces are balanced. Then, yung salitang balance is ginagamit siya to describe the equilibrium situation. So, pag sinabi nating equilibrium, ibig sabihin, ang net force is equal to 0 and the acceleration is equal to 0 meter per second squared. And this extends from Newton's first law of motion. But having an acceleration of 0 per meter per second squared does not mean that object is at rest. Kasi ang object at equilibrium is either is at rest and staying at rest or in motion and continuing in motion with the same speed and direction. And this too also extend from Newton's first law of motion. So, we have the three types of equilibrium. We have the stable, unstable, and neutral. So, a system is said to be stable equilibrium when displacement from equilibrium experiences a net forces in a direction opposite to the direction of the displacement. And an example of this is the marble at the bottom of a bowl that will experience restoring force when displaced from its equilibrium position. This force moves it backward the equilibrium position, and most systems are in a stable equilibrium, especially for a small displacement. So, next one is the unstable equilibrium. So, the second type of equilibrium is the unstable equilibrium. And a system is unstable equilibrium when displacement experience a net force or torque in the same direction as the displacement of equilibrium. A system is in unstable equilibrium accelerates away from its equilibrium position of displacement even slightly. An obvious example is a ball resting on the top of the hill. Once displaced, it accelerates away from the crest. So, the third is a neutral equilibrium. A system is in neutral equilibrium if its equilibrium is independent of a displacement from its original position. An example of this is a marble on a flat horizontal surface. Combination of this situation is possible. For example, a marble on a saddle is stable for displacement toward the front or back of the saddle and unstable for displacement to beside. And note that the basic condition for equilibrium are the same for all types of forces. The net external force must be 0 and the net torque must be 0. This equilibrium is very essential, like most especially the stable. Another important thing to know is that engineers and architects strive to achieve extremely stable equilibrium for buildings and other systems that withstand wind, earthquake, and other forces that displace them from equilibrium. In analyzing a static equilibrium situation, if an object is at rest and it is in a state of equilibrium, then we would say that the object is at a static equilibrium. Ang ibig sabihin ng static is stationary at rest. And the most common application involves the analysis of the forces acting upon a sign that is at rest. So, for example, consider this picture. Draw lang muna natin. So, this picture hangs on the wall and this picture is in the state of equilibrium. And thus, all the forces acting upon the picture must be balanced and all the horizontal components must add to 0 Newton and all vertical components must add to a 0 Newton. So, the leftward pull of cable A, let's say ito is cable A, must be balanced by the right pull of cable B. Ito, letter B natin. And the sum of this cable, the cable A and the cable B must balance the weight of the sign. Yung sign na ito. Suppose the tension in both of the cable is measured to be 50 newtons. Equals to 50 newton. Same lang din dito. 50 newton. And the angle each cable makes with the horizontal is known to be 30 degree. 30 degree yung angle natin. 30 degree. And ang question is, what is the weight of the sign? So, this question can be answered by conducting a force analysis using the trigonometric function. So, sinabi natin that can be answered by conducting a force of analysis using the trigonometric function. So, ito na. 2 is 50 Newton. Angle na 30 degree. So, sine 30 degree equals to measure all over Newton. So the weight of the sign is equal to the sign of the sum of the upward components of tension in the cable, itong dalawa. Thus, a trigonometric function can be used to determine this vertical component. Since each pulls upward with the force of 25 Newton, then yung kabuuan, the sum of this cable is 50 Newton. Then, ibig sabihin, ang bigat netong sign na ito is 50 Newton. Therefore, the force of gravity is 50 Newton down. The sign is weight 50 Newton. The next topic that we are going to discuss is the D'Alembert's principle. So, ano itong D'Alembert's principle? So, the D'Alembert's principle is the alternative form of Newton's second law of motion stated by the 18th century French polymath Jean-Léron D'Alembert. In effect, the principle reduces a problem in dynamics and statics. And the second law states that the force acting on a body is equal to the product of mass and acceleration of body. But in the D'Alembert form, the force plus the negative of the mass times acceleration of the body is equal to 0. In other words, the body is in equilibrium under the action of the real force and the fictitious force. The fictitious force is called an inertial force. Inertial force and reverse effective force. So the Alembert's principle is a concept where there is inertial force and is always have the system of mass times acceleration itself in opposite direction. So the Alembert principle is absolutely based on the Newton's second law of motion. So in dynamic structure of problem, there are three principles of law that we have to know. And the first law is the Alembert's principle. Suppose we have a mass, then we have the unbalanced force of function of time that influence the mass, and the forces will move and accelerate in function of time. So we know that this V is the displacement, B is the displacement, and we can write this in an equation as P function of time is equals to mass times acceleration. And we know that the acceleration is the second derivative of displacement by the time. And we can write this equation. We can write this equation in equilibrium principle. P function of time minus mass times the second derivative of displacement by the time is equal to 0. So ito siya. So this equation is equilibrium principle with mass times acceleration, and it is called inertia force. And so the Alembert principle is a concept where there is inertia force and is always have the system of mass times acceleration itself in opposite direction. Now let us apply the principle given by Jean-Léron d'Alembert. So consider a block of mass 40 kg acted upon by a force P, which act an angle of 30 degrees with horizontal. So due to this force, the block is moving with acceleration of 2 meters per second squared. Now given the coefficient of friction Uk is equal to 0.3, then find the force P. So we will consider the motion of block in system. Inertia force MA is applied in the opposite direction. Therefore, by the Alembert principle, summation of all forces and a product of mass is equal to 0. Now, applying the principle in x direction, then we get the equation 1. And now, applying the principle in y direction, we get the equation number 2. On solving equation 1 and 2 simultaneously, we get the value of force P, and force P is equal to 194.61. So what is the application of the Alembert principle? Even in the course of fundamentals of kinematics of machines, this principle helps in analyzing the forces that act on a link of a mechanism when it is in motion.